We now have a case study from the world's fourth largest iron ore producer, Fortescue Metals. Andrew Brown is the lead control systems engineer, and in 2013 the Solomon Iron Ore Project implemented the largest single site-based implementation of PROFINET worldwide. The delivery of the operational mindsets and ore producing facilities was achieved in record time. Significant consideration and planning was given to the selection of the communications interfaces and protocols that would underpin the critical backbone process control architecture for the plant. A combination of PROFINET and PROFIBUS was used to meet these requirements. The early design decisions for a standardised-based system, clearly defined, versatile and visionary, would have a far-reaching impact on future operation capabilities and opportunities for the integration of advanced control-based solutions. Andrew's presentation, a Fortescue Solomon Project success story, rapid control systems integration on a massive scale. Thank you. Thank you.
Thanks very much, Andrew, for that introduction. Ladies and gentlemen, as you know, my name's Andrew Brown. My background is 6 years at FMG in various roles. I'm a process chemical engineer with a focus on control systems. I have a passion for plant intelligence, and I started with the T155 expansion for Fortescue at FMG. This was a considerable leap forward in the direction of FMG from an initial fledgling 45 million tonnes a year to move to 155 million tonnes a year. I've got our FMG disclaimer. It's not something that I expect you to read, but it's a key part of presentations coming out of FMG, and I'd like to share with you a little bit of background to FMG, because I think it positions this presentation really well. First of all, the thing to keep in mind is the Fortescue values, which are generating ideas, frugality and determination, and we compel our organization to continually reflect, change and evolve. The focus is on what we can control, and that leads well into our central part of FMG as the control focus. It's pretty exciting to have been at the central core of that, and as you'll all appreciate here, that the control systems and communications networks that underpin that kind of operation across our enterprise are absolutely critical to ensure that we are putting tons through our OPFs and onto our ships. We obviously have managed to really make some massive progress over the last years, through from 2008, and having had the systems in place to move on from that 155 million tonnes to 165 million tonnes almost immediately after we had completed final production of our Solomon site. Costs and production, controlling the controllable, those are the key focus for our engineering team. Strategic delivery of targets. This just shows again from the video our specific Pilbara hub and feeding through to our port. And I'm really wanting to focus on the Solomon Project. Just backing up slightly, in terms of our history, our control system is based on a GE process architecture backbone. We invested in the GE PLC architecture and the GE Simplicity SCADA to deliver our control interface to our operators. When we moved across to the Solomon Hub, we were looking to improve across some of our capabilities, and we were looking for a more modular approach that would deliver the functionality in a simple, repeatable format for our users. Solomon was an opportunity to benefit from a critical change in the iron ore market, and the opportunity to mine Solomon came about very rapidly, and the requirements to deliver a working, fully production facility at Solomon were very rapidly thrown back at the engineering teams, giving us little time to really pre-plan and forcing us to make some rapid decisions. So we can see here from 2011 the initial development of the engineering, and the first ore being mined 2012, and we had the plants fully operational in 2013. First of all, our first OPF, ore processing facility at Firetail, and secondly, our King's ore processing facility. At Solomon, there is 70 million tons per annum of processed ore produced through the two OPFs. The significant size of the plant includes the 3 crushing hubs, the 2 massive ore processing facilities, and then 15 kilometers of overland conveyors, a significant stockyard, and a range of non-process infrastructure. We move through our mine site 165 million tons per annum. So the Solomon framework had to be rapidly developed. Now, that was against the fact that at FMG we embrace new technologies. We believe that that's a deeply ingrained part of our culture, and we continuously strive to look for ways to optimize those aspects. And it was against that our team, the owners team for FMG, were looking to ensure that we had a standardized approach to addressing these key requirements. The size of this plant and the amount of physical infrastructure that would be needed to actually deliver this project meant that it could not physically be done in the timescales by a single set of contractors. So the works were split across 7 different design and construct contractors who would provide the different sections. So you can see up here we have our OPFs. This overview just shows the total scale. The distance between King's OPF and the stockyards is about 15 kilometers. King's OPF is a massive processing facility on its own. Firetail OPF being our initial processing facility, and then other key infrastructure is our power station, our stockyards, and then our crushing hubs to feed the OPFs. And then we have ancillary equipment out here, which is our diesel storage. And all of these areas needed to be engineered and delivered together. So the challenge for us was to provide a solution that gave a framework to the individual contractors to deliver against. And the vision was really brought together by our central engineering team in conjunction with a partnership with system integrators who we had obviously needed to provide an overarching architecture to bring the individual units under a single control banner. We were looking for a completely centralized control to control this whole site from a single point, but we needed to deliver for each individual unit control on its own. So we had to coordinate that you could run the crushing hubs, for example, on their own, and you could run the OPF totally islanded. We worked closely with GE to develop the base tests in order to achieve this, and we worked closely with I&E Systems, who managed our system integration and provided core system integration support to a number of our design and construct contractors, and with Calibre, who provided us our communications networks support. And it was against that in rapid time that we came up with our centralized plan to deliver a base to operate from. We also utilized the DAD system, which is a dynamic access database, providing us with the capability to model end-to-end our electrical circuits and through to our communication circuits, so that we have a digital generated model across our sites rather than being paper-driven. This gives you an overview of our network infrastructure, or our control infrastructure. Because of the requirements that would be standardized or suggested by our DNC contractors, we couldn't force them to utilize a single framework to deliver against. In many cases, you have vendor-supplied systems that would need to be supplied in order to deliver the functionality that was required. And whilst we were able to get our crushing gear and some of our scrubbing gear and our large gear supplied as modular units from various different sections in the world, we were also going to have to integrate with other vendor-supplied units that we just could not get to conform to specific requirements. So we had to have a fairly open base to work from. And we had done the testing with PROFINET, and we'd satisfied ourselves that we would be able to deliver a stable and versatile base control system for our entire PLC networks using PROFINET, and interfacing to all of our marshalling panels using that technology. And then we were going to bring in, where needed, via PROFIBUS PA or DP, and converters in those communication panels back to the central PLCs. So this was the framework that we supplied to our DNC contractors to highlight to them the basis. We had a number of different marshalling panels of various different types that we provided to them, and they would need to adopt those as a framework to work against into their standards and their documentation. We really benefited from PROFINET. The capability to utilize the PROFINET controller, PROFINET scanner inbuilt features in conjunction with a significant role that ProfiTrace obviously played for us in order to train up our system integrators and our switch room manufacturers. And at the same time, we are having marshalling panels built by a range of different contractors as well. Afforded us the opportunity to pre-test in a integrated FAT environment in Perth prior to dispatching our switch rooms and marshalling panels up to site. So we were well ahead, knowing that our marshalling panels and networks would work, and we were able to satisfy the necessary requirements for the project ahead of arriving on site. And that saved us critical time. Our PROFINET infrastructure was, or our communications networks were centralized on a ring format, and we were able to, early on in the scopes of the works, define a lot of our SCADA interfaces using the standard diagnostics which are available with the PROFINET scanner and controller in the GE architecture. We were able to grab that information back into a centralized format and display it on standard class object faceplates. And this kind of information now underpins our process control networks, and the value is immeasurable. The guys don't even realize how easy it is to do this kind of troubleshooting. We've enhanced on these features, which are individual to a specific controller, to provide matrices which give a heat map across the site, which give us a status based on history and real time of the current PROFINET infrastructure. And in the same way, we run diagnostics across our PROFIBUS infrastructure as well. So this is a standard schematic I just put together. It's pretty rough compared to some of the ones we've seen, but it's really just to highlight the basis that an individual design and construct contractor was looking to use as a base for their delivery. So we were looking for our marshalling panels, the section at the bottom left there, which is our PROFINET ring. Pure infrastructure with no need for extra switches, no need for extra networking gear, and the capability to rapidly diagnose issues made it a lot easier for our commissioning team on site. And then where we needed to, and where we were interfacing with our drives of various different supply and various different vendor supplied units, we have still using the PROFIBUS protocol. We have our dual redundant network rings that provides interface between each of our PLCs within the specific unit operation or operating area, and then we connect up through our network switches to a redundant SCADA server pair, and in time we integrated the entire set, so we had 7 SCADA servers or redundant pairs that brought that whole network together. And subsequent to that, we have virtualized all of those SCADA servers into a central base, and we run redundant base to service that requirement for our site. So we have progressed to a more modular base with a redundant virtual environment that delivers the end-to-end functionality to the SCADA layer and to the operator. So that really gives you an overview of our PROFINET side. We still do use, or we use PROFIBUS extensively across our sites, and we have examples of being able, through that infrastructure, to interface with advanced process controllers, delivering capability for some pretty special extra control, which is certainly special across a mine site, whereby we can visualize either a train loadout using lasers or reclaimer performance using radar, or for that matter, a lot of other different functionality. We found that this is easily deployed and provides quality information back to our stakeholders. The level of delivery that we provided across our mine site was certainly at a significant industry level at the time, and spreading across 41 switch rooms, 240 marshalling panels, a massive fiber input, and the capability for, across that mine site, a process control team of 3 process control engineers, a full operations team of 4 operators, who are able to monitor and control that site is a significant delivery for FMG, and it's provided the opportunity for us now to interface that information back and potentially look at our remote operations, which really is the next step back to a Perth centre for this OPF, and certainly has already happened across some of our other sites. I wanted to just finish off with a section of where to now. What does that mean for us with our engineering team, and what are we looking to do in order to benefit from the architecture and base that we have built for FMG? Because this presentation or this forum is obviously critical to us in terms of meeting the requirements for FMG, which is to continually improve. FMG has developed over a range of years. We're a company that, like many others, started obviously greenfields, but rapidly we're brownfields, and we've put in place standards, we've put in place infrastructure, and we have teamwork who are focused on, or teams who are focused on various different areas of the business. And it's all very well to focus on statements like the Internet of Things, but what does that mean to the standard users? This slide really just shows the IT, OT infrastructure from an IT perspective within our business. And as you can see, missing from this is really our control networks. And yet it's the control networks that are the key part of the delivery. It's the control networks that provide the data that the rest of the reports that are in this slide are based on. And I need to value that information, and the status of the controllers and the instrumentation is the critical factor that we're working hard to provide. So we're working on a focus of people, process, and technology in order to bring this together. And this is an active work, ongoing works within FMG. We're looking to have clarity of the areas of responsibility and improve on those interfaces so people really understand what the capability is. We're looking to highlight the process issues. We're looking to highlight that there is a need for a fundamental philosophy for our teams to work against, and we need to involve everybody in that philosophy, the development of it, and it's underpinned by the base information that we can gather back from the process. And we're looking to utilize the necessary technology that is available to us, standardize against it, but keep our standards flexible so that they can be improved on. We are looking to clarify our hardware and our software, maintain our change management systems in a format that facilitates backups and version control, licensing, planning, and support, and a basis to manage our interfaces and work allocation. We need to ensure that we are getting information to the right stakeholders. One of the dangers is with a process control base is the process control team becomes custodians of the information, and it's a call to process control to resolve issues. And as a chemical engineer, process engineer, that's incorrect. Really, the custodians are the process engineers or the maintenance engineers. And it's about getting the right information back to them in the right time so that they can resolve those issues, and then having that base supported by our control systems. More to a collaborative and innovative environment that brings the various different stakeholders together, and to encourage them to work together as we progress this in a real mine site. To finish off, I'll just highlight some of the benefits that we've seen with FMG, because it's against our drive for innovation that we've been able to achieve the optimized benefits that Solomon Mine brought to our overall infrastructure, which was to provide a blended iron ore that delivers a more valuable product to our client base. We have improved our ore bodies by doing that, and we are focused on future technologies in order to deliver what will underpin us for the years going forward. And this is seen since the inception of Fortescue, since the inception of Solomon as a project. Our drive from a base of $48 a tonne for our C1 capital per tonne cost over the last years to this year to a base of $13 a tonne, which is a massive drop, I'm sure you agree, could only be delivered on the basis of embracing technology and the available opportunities that there are from that. So that continues to be a significant driver, and that's a great thing to have as a fundamental motivator for our teams. So these are the things that FMG is pretty proud of. This is a significant slide for us in our weekly meetings. To be the lowest cost producer, to be world class, to maintain our unique culture, and to drive our value up by maintaining a run rate of 165 against reduced downtime. Thanks very much.